Okay, so hello everyone. In this video, I will be talking about this question: minimize maximum of array, which is today's daily task on Leetcode. So in this question, you are given a zero index array nums consisting of n non-negative integers. In one operation, you must choose an integer I such that it lies in this range, and the value of the chosen integer, the value of the chosen index is greater than zero. And what I can then do is I can decrease that value by one that I have chosen, and I can increase the number which is previous to that index. So I can increase the value of nums I minus 1 by 1, and I need to return the minimum possible value of the maximum integer of nums after performing any number of operations, right? So this is what the question is asking. Now, because this is a minimizing the maximum kind of a question, and if you don't know already, let me tell you that these kind of questions, like the minimizing the maximum kind of a question or maximizing the minimum kind of a question, are always solved using binary search on answers. So if you are not familiar with that concept, you can find some videos on YouTube to get an understanding about what that actually is. And once you get the understanding about the binary search on answer concepts, you can then watch this video to understand better how we can solve this question efficiently using binary search on answer. Now, on what value I need to binary search, I will always, because the topic is binary search on answer, so I will always use binary search on the value that I need to return in the final answer. So I will binary search on this value, the minimum possible value that I can get. Now all that remains is just to check if for particular mid that can be my answer or not. So how I will do that? So for that you can have a look at this image. So let's say these are the two values. Let's say this value is, let's say these are just two values and I am representing them histographically, right? So I am representing them in form of histograms, right? So let's say this value is 4 and this value is 6, and let's say take this value as 8. Now let's say at some particular time the value of mid is 6, so this line actually represents the value of 6. So these are like the values 1, 2, 3, 4. So because this value, like this bar actually represents the value 4. So as you can see also, this actually is at this height only. So I'm just trying to explain you that these height just represents the value of that particular index. So let's say for at some particular time the value of mid is 6, so I can see that I can increase this value by 2, because if if at some particular time the value of mid is 6, so I can have, I'm considering the current maximum that I can get to be 6. So I need to ensure that all of the values in the array are at most 6. They cannot be more than 6, because I'm assuming that the maximum value that I currently have is 6 at the current time, right? So what I can then do is I can see that I can efficiently increase this value by 2, and I can simply increase this value, I can simply decrease this value by 2, right? Or we can also have 7. So in case you have 7, so the difference will be 1. The difference between 6 and 7 will be 1. And if I have the value of this particular index as 8, so I can see that the difference will be 2. So now I can see that as long as I have the difference as 1 or 2, I can efficiently perform this operation, right? I can efficiently increase this index by 2, and I can efficiently decrease this index by that much value. So this value is 2, so I can efficiently decrease this index by 2. So but just in case, let's say this value was, or let's say this difference was 3, so you can see that because the difference here is 2, so I can only decrease this index by at most 2. I cannot decrease it by a value that is larger than 2. So I can see that if at any point I get a value that I cannot reduce to a value that is lesser than the current value of mid, I can say that at that point the answer will not be valid, or better say that value of mid will not be valid. So this is how I will do it for at some particular index. I will first check if this is already like smaller than the current value of mid, so I can efficiently increase the next indexes by that much value. And if at some particular time the value is greater than mid, so I need to check if the previously accumulated values are greater than or equal to that value or not. So in only in that case the value of mid will be valid, and in all other cases the value of mid will not be valid. So this is how I can efficiently solve this question. Now let me show you what I'm doing in the code. So as you must be knowing that in binary search we need two ranges. So I'm taking these two ranges as low and high. So the minimum value that I can get is 0, and the maximum value in a array can be the maximum element in the array. So these are the two ranges that I'm taking, and initially I'm taking the answer as maximum value because if I'm not performing any operation, I can see that the answer will be equals to the maximum value in the array, right? And this is the syntax of the binary search. uh, Binary search, you must already be familiar with it. So in this, what we actually do is we run a loop while low is less than or equals to high, and we find the value of mid using the values of low and high, and uh, and we make a predicate function. So this predicate function is a boolean function which simply checks if the current value of mid is true or not. So I will just check if this particular value of mid is true. So if it is so, I will store this value of mid in my current answer, and I will try to find a lesser answer. So I will make high equals to mid minus 1, because I need to minimize the maximum possible value. So for that, what I will do is I will make high equals to mid minus 1. So what this means is I will try to find a lesser answer. Although I have got an answer, but I will still try to find a lesser answer. So that is why I am doing this. And in case the current value of mid is not valid, so I will try to find the answer for higher values of mid. So I will make low equals to mid plus 1, and in the end I will simply return the answer. Now let's talk about the checker function, which is the core of this question, like how we will perform the operations that I just described in this picture. So let me tell you. So I'm taking n as the size of the vector, and I'm running a loop from 0 to n minus 1, and this stored variable, I will tell what this stored variable actually holds. So what I will do is I will calculate the difference, and if at some particular point, let's say in this case the difference will be positive, right? So in this case the value of diff will be 2, and as I can see, if a value is positive, so I can simply include in the values that I have currently accumulated. So I will simply add it to the total variable. So this is just kind of a just this variable actually holds that how much I can decrement the current index by, right? So as I can see that because the current difference is 2, so I can decrement the next indexes by 2. So this total variable, or better say the total variable, will actually hold by what amount I can decrement the current index. And so this is what actually total variable holds. Now what this is for, so consider for this index the difference is 3. So the value of diff will be minus 3, because I'm doing val minus v of I. So currently the value of val is 6, and if the difference is 3, so the value of vi will be 9. So this is the case which is actually not valid. So when I do 6 minus 9, it will be equals to minus 3, and you can see that the previously accumulated values of total was 2, and if I do 2 minus 3, it will be a negative value, right? So so what this means is I can only decrease the current index by 2, and even after doing that I will be left with some value which is greater than mid. So in that case I need to return false. So this is what this if condition is for. So if at some particular index the value of currently accumulated values and the current difference is less than 0, so in that case I will simply return false. And if I I run this loop, and in none of the cases I get a false, so I will simply return a true. So this is how I can solve this question efficiently. And at certain points I have taken long values so that I do not get a integer overflow errors, because as I can see that the constraints are the value of n can be up to 10 raised to the power 5, and the value of num psi can be up to 10 raised to the 9. So I can see that the values can overflow, or better say the values that I'm handling currently may exceed the integer size limit, right? So that is why I'm at certain points I'm taking long to handle those cases. Also, let's talk about the time complexity and space complexity of the solution. So the time complexity of this solution will be O of n log n, because this run like this loop will run log n times, and inside this I'm running a O of n time loops. So this loop will run for O of n time. So I can see that the overall time complexity of this solution will be O of n log n. And the space complexity, because I'm not using any auxiliary space. So if I ignore this part, like the part that is given to me in the input, I can see that the auxiliary space that I have used will be O of 1. So this is the overall time complexity and space complexity of this solution that I just discussed. Hope you understood it. Thank you.